The main objective of our project is to help people with sight disabilities to detect and avoid obstacles. The strategy is simple. The components we use are 3 sharp IR proximity sensors and a music shield to produce audio instructions. We have chosen IR proximity sensors over ultrasonic because we wanted higher precision, accuracy, and a minimal interference over extended ranges. 2 of the sensors are located at the right and left sides of a glasses that the person is going to wear, and another one at the center of the glasses. The edge sensors help navigate to the opposite side with no obstacles, and the center sensor prevents collision with obstacles in front of the person. The default is for the person to keep moving forward until he receives an assistant from Morgan Freeman.
Modeling the problem in software was tricky because of the speed of execution of the Arduino C language. One of the main problems we faced in configuration is that the code iterates over the sensors to read their values in a much faster rate than the rate of change of values from the analog ports, so some conditions are not met and the code is stuck in some places for a limited amount of microseconds, which on the long run caused problems playing and syncing correct audio instructions for the person. We solved this problem by structuring the code in a way to make the center sensor values independent on the values read from the other 2 sensors, and we start taking the values read from the side sensors into consideration only when the center sensor is not detecting anything in front.
Our project, we navigate the person using audio instructions in the voice of Morgan Freeman. And now I will talk about the method we use to perform that. Reduce a sound, so we get a wave shield. However, this shield didn't work, as it needed SD card less than 1 GB to store the sound files on, which is not available in the market. So we used an MP3 shield. This shield can load the sound files from 8 GB SD card or a flash memory. This shield takes commands from the Arduino through the serial pins. It can either use the Arduino's TX and RX pins or use pins 7 and 8, which is the safer case, because the Arduino already uses TX and RX to be programmed.
So, in the programming of the Arduino, we used the software serial library that allows serial communication through specified pins. Then, using the shield datasheet, we send commands to the shield through the new serial pins. Each command is a series of bytes that are saved in a buffer and then written one by one on the new serial pins. We made 4 functions. The first one was to write the buffer on the serial pins. The second one filled the buffer with a command that changes the volume. The third one plays a specific track from the SD card. And the fourth pauses at running track. These 4 functions are all called consecutively to play a specific track when needed.
Hazard ahead. Let's avoid all clear and present dangers. Turn left. Turn right. Turn right. Turn right. Turn left.